Hello viewers, welcome back to class. I'm super excited to have you guys back to class. This is Master Builders Online Academy. If you have forgotten, and don't forget to subscribe to this YouTube channel if you have not done so. And ensure that you turn on the post notification bell for more exciting videos. Guys, don't forget to share, don't forget to like, and don't forget to make your necessary comments. Now listen carefully. Let me quickly remind you one of our policies. Do not skip any part of this video. This is for your own benefit. This will help you not to skip vital information that will help you gain mastery over this aspect of our lesson. And secondly, anytime you are set to watch and to learn from our platform, avoid every unnecessary distraction. This will do you really good. And finally, if there be any part in this video you do not understand, maybe when you watch it for the very first time, please guys, you have an opportunity to replay the video over and over again. In fact, you can replay the video million times. And that's why most of our lessons now, they are coming in video format. This is to help you gain mastery. And finally, guys, don't forget that when you understand principles, you suddenly become a principal. And when you understand boundary conditions, you will not overstep your boundary. Take this to heart. Let's get to work. Don't be anxious of solving problems. First of all, understand the basis of what you need to do before you start solving problems. Don't skip any part. Don't dive into the calculation when you do not know what you need to have before you can start solving. Now, this is what I want to quickly read to you before we start solving these problems. Now on the board, don't forget we are still looking at solutions to what? Second order differential equation under case 2 when f of x is not equal to 0 or f of x is equal to any functions of x. Of course, this you have known. Alright? Now we are looking at case B, or we are looking at another category under this case which happens to be or be part of it, where we have linear function. In our previous lesson, we looked at constant function. Now we are looking at linear function. How does linear function comes? Linear function comes in such a way that the power of x, because here we have x all true, the power of x is 1. Now the f of x is always given as kx. When I mean kx, it can be given as 3x. K is constant, an integer, a number. Alright? It can be 50x like we have. It can be 3x minus 2 or 3x plus 2. This is linear equation. It must not necessarily just be 3x. You can have 3x plus 2. This is linear. What you look at for is the degree of x. Alright? So this is all about this aspect of it. Now, anytime you are given linear equation, what do? All you simply do, guys, is to what? Obtain your particular integral by equating y equal to cx plus d. This is it. So in this case now, we are going to be what? Obtaining the true value of c and the true value of d. And I explained earlier why the constants start from c and d, because the complementary function already contains two arbitrary constants which are a and b. And here the arbitrary constant is now c, d, e, f, just like that. So we are not going to be using a and b here because they already exist in the complementary function. So, but for the purpose of the particular integral, we actually get the true value for c and d or any other variables or constants that we have there. Are you there? This is how it is. So now, for us to be able to find this and this guy, there are things we need to do when we get there. So first, we have question number 1 on the board under this category, which happens to be question number 3, based on the fact that this is a continuation class under case 2, as you see under the title of this particular video. Are you there? Now we are asked to solve this square y over the x square plus 6 the y over the x plus 10y is equal to 50. Now very quickly, let me quickly take this as equation 1 because I need to have a lot of space. From equation 2, we know that the general solution here, because I explained earlier that you must take the future from the very beginning. So for us to do that, we know that the general solution would have been a combination of complementary function plus particular integral. Why? Because the second order differential equation here given is equated to 50x. That is to say the right hand side is not equal to 0. So anytime you have second order differential equation whereby the right hand side is not equal to 0, you automatically know that the general solution must be a combination of the complementary function and particular integral. That's the reason why we just define this. Then, having known that this equation 2, we therefore know that for us to be able to get our final solution today, we need complementary function, then we need particular integral. Now, guys, it's a matter of choice to first of all find complementary function, then go for the particular integral. But I always prefer that you solve for particular complementary function first before the particular integral. Of course, both of them, they are independent of each other. The answer you get here is independent of this, and the answer you obtain here is also independent of this. So you can choose to solve for any of this option here, right? But let's solve them serially. Since we have complementary function first, let's solve for complementary function, and I urge you to always do that, okay? Now, to be able to solve for complementary function, we said that this second order differential equation must be equated to 0. That means the right hand side of this equation must be 0. And how do we have that done? Then we need to state that f of x is equal to 0 so that we can equate the right hand side of this equation to be 0. It is only on that ground that we can obtain the auxiliary equation that will help us to find the roots of the equation. Hope you got that. Now, therefore, we now say okay to find the complementary function, comma, to find the complementary function, let the right hand side or f of x, whichever case you want to state it, is left for you. But let's use the right hand side be equal to 0. So what do we mean now? We therefore have that d squared y over the s squared plus 6 dy over dx plus 10y is equal to 0. You can call this equation 3. Now that we have gotten equation 3, guys, the next thing we are quickly going to do here is to deduce the what auxiliary equation, having equated the right hand side to be 0. And to deduce the auxiliary equation, all we need to do is to change this square y over dx square to m square, the y over dx to m, and y to 1. Therefore, when we do that, this will have given us m squared plus 6 multiplied by m plus 10 multiplied by 1, which is still 10, and this is equal to what? 0. Then we have this as equation 4. Now that we have equation 4, guys, what's the next thing? The next thing is to check equation 4. What must we do here in equation 4? We see that equation 4 has turned out to be what? A quadratic equation. And for every quadratic equation, we have two roots, and there are multiple methods of providing solution to quadratic equation. And now let's look at this equation. From my own observation, I already know that this equation is not factorizable, alright? And I taught you yesterday how to have that done, 2 ways to check it out. So without wasting much of our time, let me just check it out for you. I already know, okay, but let me check it out for you. Now look at it. I said yesterday to check out whether a particular function is factorizable, we use this equation. B squared minus 4ac. And this is giving us what is b? B is the coefficient of m. That is 6 squared. And 6 squared is 36. Minus 4 multiplied by a is the coefficient of m squared. So 4 multiplied by 1 is 4. Then 4 multiplied by 10 would have given us what? 40. When we remove 40 from this guy, we have this to be what? Minus 4. And I explained that anytime you have negative inside the square root, it shows that this expression is not factorizable. Hope that is clear. So we are quickly going to use what? The quadratic formula. Now that we have m squared here, the quadratic formula is m is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Alright? And I also equally explained that you must take this formula before you substitute. Once you state this formula, you need also to state the parameters where a. So you come here, compare the coefficient of m squared is 1, b, coefficient of m is 6, and the constant is 10. This will accrue you a reasonable mark. And that's why you don't need to jump. So there are steps you don't jump. Alright? Now at this point, we then have that m is equal to minus 6 plus or minus the square root of minus, okay, this is not minus, 6 squared minus 4 multiplied by 1 multiplied by 10 all over 2. All over 2 multiplied by 1. So from here you can get your answer, guys. Once you get to this point, It's possible to have a final answer, but these two steps must not be skipped. But from here, now you can get your answer if you don't want to simplify further as such. But let's just simplify for like 2 or 3 lines. This is plus or minus the square root of minus 4. Hope you understand how I got this. Okay? This is what we have. This will give us 36. And this will give us 40. 36 minus 40 will give us minus 4. And I explained here in our previous lesson that when you have a negative inside the square root, to remove the negative, introduce imaginary sign. Are you there? So we can have this as minus 6 plus or minus. This is imaginary sign. Then you can now take this as positive. When you find the square root of positive 4, you will have 2 all over. Okay? At this point, all we just need to do now is to have that n is equal to 6 divided by 2. We have minus 3 plus or minus 2 divided by 2. We have 1. So we ignore the 1. Okay, now at this point now we see that this is what complex root, and for complex root n is equivalent to alpha plus or minus j beta. Imaginary. Now from what we have here now, it shows that alpha is equal to minus 3 and beta is equal to what? 1. That's the coefficient of what the imaginary sign. If this is understood, then I will now recall when I have complex roots, what is actually the general solution? Are you there? Yes. What is the general solution? So you can begin to crack your brain. Yes, you can begin to crack your brain. And if you have this done there, you just remember that y, general solution is equal to exponent alpha x into a cos beta x plus b sine beta x. You see, no examiner will do this for you. This one is your own. That's why you may be good with such quadratic. Now, if you have your answer, just as we have now, if you do not remember this, where are you going? So you need to put all these formulas here. Are you there? Okay. Now, finally, we have this as equal to what? When we have this will have given us minus 3x, open bracket, a cos. Beta is 1, so this will have given us 1x, we ignore 1x, plus b sine 1x. This is the complementary function. So you can decide to replace this y with complementary function, CF. Okay? Now we have obtained the complementary function. The next thing we have to do is to find the particular integral. Now, for us to be able to find the particular integral here, all we need to do is to find particular, let's abbreviate it, particular integral. Understand that, now to find particular integral, understand that particular integral is equal to y, and y for linear equation. Then you come to the equation here, see, what do I have here? Linear equation. And what is the model, the particular integral model for a linear function? You see, Cs plus. So I now have Cs plus D. Alright? Cs plus D. That is to the therefore y is equal to Cx plus D. I've gotten y. Now that you have gotten y, the next thing you do is what? You differentiate y. All particular integrals are solved the same way. The only difference is that the outcome depends on the function you are given. Some functions exist, some do not exist, like constant. Alright? So if I differentiate Cx with respect to x, since there is x here, dy over dx would have given me C. But when I differentiate d being a constant, I will have 0. Are we there? So that means when you differentiate Cx plus d, you will have C. Now when you differentiate this again, and I explained earlier, to obtain the second derivative, you now differentiate the first derivative. When you differentiate the first derivative as, which is C, and C is constant, you have 0. This is 0. It's as simple as that. What else do we do? All we just need to do now is to substitute these 3 models here into the given equation. Don't always forget, once you differentiate first and second time, substitute y, dy over dx, and this square over dx square into the given equation, which we tag as equation 1. So we'll come here and replace this with 0, replace this other guy with C, and replace this other guy with CSD. That's all. So the first term is 0 as we substitute, plus 6 multiplied by dy over dx, we obtain it to be c. Okay, then plus 10 multiplied by what is y? Don't forget that y is cx plus d. Then all equal to 50x. Don't forget, we just substituted into equation 1 or the given equation if you decide to call it that way. Now, if this is understood, let's simplify this. This would have given us 6c plus 10cx plus 10d is equal to 50x. Now, in this case, listen carefully. You know, mathematically, it is not easy for you to obtain two unknowns from one equation. And that's why the aspect of simultaneous equation comes in. When you have two unknowns, you need to have two equations to be able to provide two solutions to it, right? But in this case now, there is a way to find two unknowns or multiple unknowns in one equation. How do we have that done? We use comparison methods. Listen carefully. How do I say? We use comparison method to obtain numbers of unknowns from one equation. Now, how is that done? If you are good with partial fraction, you obtain b and a from one equation, then you understand what I'm trying to say here. Now, from here, let me collect the constant. Understand that this is with x, but this guy and this other guy are not with x. So let's start with the one with x first. 10c x plus 6c plus 10d is equal to 50x. So for us to be able to solve for d and c, all we need to do is to do comparison method. Now, by comparison method, like I said, because of this fact that the space of the board it will not be enough, I will minimize this. So to compare, we check. Here we have x, then we have the ones without x, which we call constant terms. Are you with me? We are going to equate functions that carries x, and we are equally going to equate functions without x. So when I come to the left-hand side of the equation, the only function that is carrying x here now is 10cx. So I will remove x, I will be left with what? 10c. Then that's the only x I have at the left hand side. Then put down your equal to. When you come to the right hand side, I have 50x. So when I remove x from there, I have 50. I will call this one equation A, or any equation you want to call it. You can call it, you can continue from the number of equation you have here. But let's call it an equation A. Are you there? Then the next is what? Constant terms. Constant terms are terms without x at all. Are you here? Now, if that is understood, now I have this without x, which is 6c plus 10d. Then at the right hand side, do I have a constant term? No. I do not. So since I do not have a constant term at the right hand side, then I take it as 0. Is this understood? If it is understood, then you are done with this. You are good with it. That's all. This is the only difference between what we have done in other constant function and this. It's as simple as this. So now finally, guys, all I need to do now from equation A, I can find C. Because equation A contains only one unknown, which is C. So from here now, from equation A, C is equal to 50 divided by 10. Because we need to divide both sides by 10 to obtain C. And C would have given us what? 5. This is the answer. That's all. Then from equation B, also, what do we do here? From equation B, we also know that 10d is equal to minus 6c. Why do I want to make d the solid of formula? That's all. Then finally, d becomes minus 6c over 10. Then this will have given us minus 6 multiplied by 5, which is the value of c, all over 10. And this will give us minus 30 over 10. Therefore, the value of d is equal to 3. Now that we have gotten the value of c and d, then we are done. All you just need to do is to come to y. Listen carefully, or come to this point. Particular integral. We said that particular integral, therefore recall that particular integral is equal to cx plus d. Now I know the value of c. I equally know the value of d. Substitute. You are done with the particular integral. So at this point, I have particular integral is equal to the value of c is 5 multiply by x. The value of d is minus 3. So plus minus, I have minus. This is the particular integral. Now, finally, guys, what will be the general solution? Now that I have obtained complementary function, I equally obtain the particular integral. The next is what? To sum up the two functions. That's it. So, and that would have been obtained using equation 2. Can you see? That's all. So, equation 2, we said that y is equal to complementary function plus particular integral. Okay? This is the general solution. Now, I therefore have y is equal to, what's my complementary function? Complementary function is e raised to the power of minus 3x all over a cos x plus b sine x plus particular integral 5x minus 3. This is the answer to this question. You see how simple this is? Very, very simple, but requires understanding principle. So you will be stranded if you do not know principles. That's why I always advise you should know principles. Now, when you know principles, you become principal. And when you understand boundary conditions, you will not overstep your boundary. Sometimes the reason why you are stranded halfway is because you do not know principles. If you know principles, you will know the next step. So, guys, don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos. Listen carefully, guys. We are quickly going to add another question to this very, very quickly. So, see you guys in that question number 4. All right. Now we are asked to solve 3 d square x over d square y over d square minus 2 dy over dx minus y is equal to 2x minus 3. Don't forget, at the right hand side, that's the major focus. It's not equal to 0. The word function is there. The function here now is linear equation. Degree of x here is 1. X raised to power 1. So linear equation. Forget about this other one that is there. It's linear equation, right? Now, what do we do first? The first thing we do is to rewrite this equation after stating our solution. Then we call this equation 1. Alright? But because of space, let's minimize this. Now, the next thing we are quickly going to do, having gotten this, is we need to what? State equation 2, which is the solution, the destination, the future. So we have to define the future from the beginning. And what's the future? What the future holds for us is complementary function plus particular integral. This is equation 2. This is where we are going. Now, the first question is, what are the methods or the ways to obtain complementary function? Similarly, particular integral. Let's go with the complementary function. How do I obtain this? First is to ensure that the right hand side of this given equation is 0. That's the first theory. Principles makes you principal. Then we have this to what? So what do we do now? To find the complementary function, we just need to find the complementary function. Let the right hand side of this equation be equal to 0. So we now have this equation as 3d square y over dx squared minus 2 dy over dx minus y is equal to 0. This will have given us equation 3. Nothing is different. It's all the same process. All the same process are involved. Then once you get equation 3, or you have successfully equated the right hand side of this equation to be 0, the next is to what? Obtain the auxiliary equation. And to obtain the auxiliary equation, we know that this is 3. This square over dx squared is represented with m squared, and this guy is represented with what? M. While this guy is represented with 1, and the coefficient is 1. So 1 multiplied by 1 is 1, and this is equal to 0. We call this equation 4. Now, from equation 4, we have obtained a quadratic equation, and from the look of things, this expression is factorizable. Now, what do? We will simply multiply this guy by this guy, and this will have given us minus 3m squared. Now, if we multiply this guy 3m squared by the constant, we have minus 3m squared. So what else do? We are only going to look out for 3 factors such that their product will give us minus 3, and their sum or difference will give us what? Minus 1. And you know that the factors of 3 is 3 times 1. That's all. Is it that you have minus 3 times 1 or minus 1 times 3? But we need minus 3 times 1 so that we can get minus 2 here. So multiplication will have given us 3m squared minus 3m plus m minus 1 is equal to 0. So if I multiply these two middle terms now, it will give me minus 3m squared. And if I add them up, it will give me minus 2m, which is the middle factor. But if you still have not understand this, then you can watch our previous lessons on second order differential equation when f of s is equal to 0, or you can go down to our playlist session and look out for quadratic equation under factorization and any other methods. Okay, now let's go. And like I explained before, you can use any method of your choice. Now that we have successfully replaced the middle number or the middle term with two other factors, then we need to group the first two terms and equally group the last two terms. Now between the first two terms, what is common? First, 3 is common and m is also common. That means we have 3m as a common factor. Now 3m squared divided by what? 3m, we are left with m, and 3m divided by 3m, we are left with 1. Now we put that this plus between m and minus 1, nothing is common. And I explained before now, anytime you are factorizing expressions and you find out that nothing is common between two terms, in that case, 1 is common. Then we put that 1, then open the bracket, m minus 1 equal to 0. When you multiply this bracket by 1, you still get back the previous outcome, right? That's it. Now that we have successfully factorized this, the next thing we are quickly going to do is to collate the multiplication factors. And what are multiplication factors? We said that multiplication factors are factors outside the bracket, right? The factors outside the bracket. And the first factor that is outside the bracket here is 3m, and the other is plus 1. Then we can now pick one of the equal bracket, which is m minus 1. This is equal to 0. And from our previous explanation, we said that for the product of two factors or functions to be 0, one of the factors must be 0. And we do not know the one that is 0. Therefore, who we assume is either the first that is 0 or the second that is 0. Then we have 3m plus 1 equal to 0, or m minus 1 equal to 0. Now we need to make m the square of formula. So first is to have 3m is equal to, when plus 1 crosses the sign of equality, it turns to what? Minus 1. And when minus 1 crosses, it turns to plus 1. Therefore, m becomes, we need to make m the square formula here by dividing both sides by 3. Then this are giving us minus 1 over 3 or 1. With what we have here now, we discover that the value we have here now, they are real. We just obtain real roots and different roots. Now, when you have real and different roots, it shows that you are going to have m1 and m2. Therefore, where m1 is equal to 1 and m2 is equal to minus 1 over 3. Like I explained before, anyone can confess. It doesn't matter. Anyone can confess. But I just prefer one to confess. Anyone can confess. Now, in this case that we have been able to ascertain the type of root that we have. What then is the general solution to the second order differential equation whose roots are real but different? We have that solution to be y is equal to a exponent m1x plus b exponent m2x. Like I said earlier, you must pay the sacrifice to know these formulas. Yes, you must pay the sacrifice to know these formulas. Now, therefore, y becomes, what is m1? m1 is 1, so I'm going to have 1s, which is exactly the same thing as x. Then plus b raised to power minus 1 over 3x. Or you can decide to put in minus x over 3. Okay? But if you don't want it that way, then you can put it as minus 1 over 3x as you wish. But let's leave it this way. So this is what we have as our particular integral. So I can decide to replace this one with the complementary function. This is what we have as our complementary function for this question. Now, what do? We need to find the complementary, we need to find the particular integral. And to find the particular integral, let's quickly state that to find the particular integral, we know that particular integral is equal to y, and y is equal to cx plus d. Hope you do not forget this. Anytime you are dealing with linear equations, this is how you obtain the particular integral. So we are simply going to obtain the value of c and d. And to have that done, we need to take this y as y is equal to y is equal to Cx plus D, comma, then we differentiate y with respect to x, dy over dx is equal to C, then d square y over dx squared is equal to 0. For every linear equation, anytime you differentiate, you always have dy over dx as C and d square y over dx squared as 0. This is how it is. Alright? Now, the next thing we are quickly going to do at this very point where we are is to now substitute these three results that we have here into equation 1 or the given equation so that we'll be able to obtain the value of C and D. And how do we have that done? We just go back to equation 1. Equation 1, we have 3 multiplied by d square over dx squared, it happens to be 0. Then minus 2 multiplied by dy over dx happens to be C. Then minus 1 multiplied by what? Cx plus D is equal to the right hand side. We have 2x minus 3. It's as simple as this. So at this point, this guy, anything multiplied by 0 is 0, so we ignore. Then this will have given us minus 2c. Minus multiplied everything inside this bracket, then we all be influenced with what? Negative sign. So minus Cx minus D is equal to 2x minus 3. At this point, let's quickly arrange. Let's take the linear function or a function with s first, then followed by the constant, just the way the right hand side is arranged. Then we're going to have minus Cx, then minus 2c, then minus d is equal to 2x minus 3. Now that you have gotten this, at this point now you have two unknowns in one equation. And I said to be able to obtain numbers of unknown from one equation, all you need to do is to make use of comparison method. This is one of the laws that contradict the fact that you cannot get numbers of unknown from one equation. Don't be anxious to just solve problems. Be anxious of getting to know what this content is all about. Okay? Now, at this point now, we quickly compare. Now, what are the functions we have here? We have a function of x and functions without x, which we call constant term. Then we have this as x, function of x, and what the constant term, which are functions without x here. Now, I will come to the left hand side. At the left hand side, how many functions are carrying s there? Is only minus c. So I will just remove the x and pick the coefficient of x. And the coefficient of x there happens to be what? Minus c, equal to, that's the only x I have at the left hand side. Then at the right hand side, I have 2x. I will remove the x and take only the coefficient of x, and that happens to be 2. So we call this one equation what? A. Let's use another equation. Then when we come to the constant term, which are the terms without what? X. First I have minus 2c. And I also have minus d is equal to, when I come to the right hand side, I also have minus 3 as a term without x. Then I have this as minus 3. Then this becomes equation A. Now B, you will always start solving from equation A because equation A will always contain the least number of unknowns. Hope that is taken. Now when we look at equation A, we see that it's just C that is there. So we can make C the sort of formula by dividing both sides by the coefficient of C, which is minus 1. So when we have that done from equation A, we have that C is equal to 2 over minus 1, and this is minus 2. When we divide 2, positive 2 by minus 1, we have minus 2. Or simply multiply equation A by minus 1. Whichever case you decide to do it, you will have the same result. But understand that C is positive at the left hand side. Now to get D, we can now substitute into equation B. Now from equation B, we have that D is equal to, now what you are going to do here is to take minus 3 to this end to become plus, and take D to this other end to become positive. So when I take D to the left, it becomes positive, already positive. Then when I take this guy to this end, we will have this as 3 minus 2c. All I just did here is to make D the subject of formula. And now we can have this as 3 multiplied by what? 2 multiplied by the value of C is minus 2. And now this will have given us 3 plus 4, and that would have given us 7. This is it. Negative 2 multiplied by negative 2 will give us positive 2, positive 4. And positive 4 plus positive 3 will give us positive 7. That's what we have. This is it. Finally, now that we have obtained the value of C and D, then we will now recall equation 1, which is this, or the particular integral. Then you will recall that particular integral is equal to Cx plus D. And what is C? C is minus 2x, and D is what? 7. It's as simple as this. This is your particular integral. Now that you have obtained the particular integral, guys, what next? The next thing is add up the complementary function and the particular integral, since you have obtained the results for the two parameters. Are you there? So you simply recall that y is equal to complementary function plus particular integral, which happens to be what? The equation we labeled as equation 2. Are we there? So we have y is equal to, what is our complementary function? Our complementary function is e exponential x plus b a exponential minus x over 3. Then minus, understand that this is plus, so this minus will change the positive sign here. We now have 2x plus 7. This is the answer to this very question. Guys, it is very, very simple. All you need to do is to understand principles. When you understand principles, you become a principal. It's as simple as that. And when you understand boundary conditions, you will not overstep your boundary. The words of the wise masters. Guys, we love you. Thank you for following us. Thank you for watching our videos. Thank you for being engaged with our content. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification button. More exciting videos when we upload it. Like this video, share this video, and make your necessary comments. Love you. See you in the next class. You can quickly check the description below where you will find a link to the next video.